2.5 gets into scatter plots and lines of regression. Any data with two variables is called bivariate, BI meaning of course two, like bicycle, two wheels. So two variate data. The graph of bivariate data is called a scatter plot or a dot plot, which is what we're getting into. The reason for the name scatter is because data with two variables is rarely organized neatly if it's realistic. Depending on the arrangement of the values, its correlation can range from the values of r equals -1 to r equals 1. Now again, this is not absolutely important right now, but this is me just telling you everything you need to know. So looking at these real quick, notice how all these dots are fairly close to each other, but they're not a straight line, but you can see that they're going in a positive direction. That would mean that you're using a positive r because of course it has a positive slope, and I believe when I typed it in, this has a r of 0.9, which means that these are actually pretty close, but they're not really straight. So again, with 1 being the max, you're only really like 0.1 off, but this is what 0.9 would look like because it's got a, again, you can definitely tell it's going up, and the lines are the dots are pretty closed in pretty well. The one over here, not as close. Notice how they're more spread out, but you can definitely see they're heading in a downward direction. I believe when I looked this up, this was r equals -0.7 or so. Again, the 7 being weaker than 1. Again, this is very close to 1, which is why they're getting close. This is further away from 1, which is why they're more spread out. But again, the fact that it has a negative slope is why it's a negative number. And then the third one is an image of something that does not go up, does not go down. This would be of r equals 0, which means that these two variables have nothing to do with each other. Again, the tightest downward would be r equals -1. So that would be something where the dots are kind of definitely straight down. R equals -0.5 would be more wide, but heading down. 0, of course, is a big blob. 0.5 is wide, but heading in an upward direction. Of course, r equals 1 is like a straight line going up. So those are the 5 things you look at whenever you're talking about the value of r, which again, you'll get into that later, but not so much for this test because it's not something that you really need to know. It's just something that's good for you to understand if it ever pops up. Each correlation that is not 0 can be summarized using a line of best fit. This line is indicate what's to be expected at a certain value. Let me get this back here and show you what a line of best fit looks like. First off, let me go ahead and take some paper and make a straight edge. So if you're ever doing work on your math and you need a straight edge and you have a piece of paper, you simply just need to fold your paper 2 times of work. So 1 here, 2 there usually does it, 3 to be really sufficient. But what you're looking at here is that now gives me a straight edge where I can kind of see what's going on. But again, your line of best fit is typically not going to be down here because that's below all the data. It's not going to be up there because that's above it. But with your line of best fit, what you're usually doing is you're finding a line that goes mostly through the middle of the data, which doing it by hand is not ever going to be really accurate, but kind of it's an eye thing. So that would be your line of best fit, which would tell you that at this point you would expect it to be somewhere around here. At this point you'd expect it to be somewhere around here, and again, you can be above or below the line, but again, it's an expectation line. Just like here, what you would do is again look at this direction, which is negative. You try to find somewhere that's about in the middle and kind of draw a line that represents what you believe to be the line of best fit. Notice how that does go between the middle of most of this stuff, and so that would be the slope of your line and everything that's going on. Again, the reason you have to have a correlation is because if your correlation is 0, you don't know if it's positive, you don't know if it's negative, and so you really can't do anything with that. But again, the line of best fit should be placed that it goes to the middle of the data. Before talking about that in depth though, let's just graph some scatter plots and see what's going on. So the hardest thing about scatter plots is that you have to make sure you leave room for these weird numbering things. This is typically your independent variable, which is going to be here. So this is going to be your depth, and this is going to be your temp. And so we need to make sure that depth can get up to 2,000. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, which means I think that every 200 should get me 2, 4, 6, 8, 1. Yep, so 200, 400, 600, 800, 1,000, 1,200, 1,400, 1600, 1800, and 2000 there. And we want to make sure that our temp goes up to 22. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I think that if we counted by threes, that'll take us up to 30, which at least gives us enough room for what we need. Again, however you number this is up to you. You just need to make sure you're as accurate as you can possibly be and that you have room for everything that you have there. So 0, 22 again means 0 here. 22 would be just slightly above 21, so 22, 23, 24, somewhere around there. 300 to 20, if this is 200 and 400, that would be 300 up the middle to 20, which would be somewhere around here. 500 to 13 would be go to where 500 is and go up to where about 13 would be. Again, it's not going to be the most accurate thing, which is why it's a scatter plot. 1000 to 7, so 1000 here to 7, which is just above 6, somewhere around here. 2000 to 6 is going to be somewhere over there. So we can see here that this has a somewhat of a negative correlation because the dots are kind of going in a downward direction. And again, what we would have to do at this point is kind of do what we need to do to create our line of best fit to the best of our ability. And again, that is where our work from yesterday is going to help us out, but we'll talk about that in just a second in terms of our options there. But again, that is your graphing of a scatter plot, and the main thing is making sure you have room for your independent variable and your dependent variable. Again, independent variable goes here, that's your x. Dependent variable goes there, and that is your y. Let's look at another one talking about family size and income. Again, whatever is listed first is usually going to be your independent variable. So family size goes there. Income's going to go over there. And we need to make sure everything fits. Of course, family size is going to be easy. I can just go ahead and skip this 1, 2, 3, and 4 just to give us some room. And then income goes up to 60,000. So 1, 2, 3. So we do 20, 40, 60. Actually, we need 60,000. 30,000 here. 60,000 there. So 30. I think that's 6 apiece. 6, 12, 18, 24. Yeah. So 6,000, 12,000, 18,000, 24,000, 30, 36. 42, 48, 54, and 60. So again, I put a K there because of course you don't want to write all those zeros, but again, as long as you've got the right idea, that's fine. 1 would be about 33,265. So 1 will go up to about 33,000, which would be, I think, somewhere between 30 and 60. Again, because there's no real grid here, just put the dot in the best location you know. I'm not going to keep bringing this down because you can look at your own, but 2 says 44,625. So again, 2 goes up to about 44. 42 and 48 is 46, so I don't want that middle part there. I want it to be lower. So that would be about here. Again, I'm probably not as accurate because I'm kind of looking at an angle. 3 is about 50,000. So 50,528. So if that's 48, it'd be 2 above that, but not close to 54. So somewhere around there. And 4 is pretty close to 60,000, which is going to be up here, somewhere at the top. So again, it's not the most accurate because I don't have the grid. But again, the general idea of what I want to show you is how these things are graphed. You are going to be asked to graph one of these on your test. You're also going to be asked to graph. Actually, we don't have a quiz this time, but again, just make sure you understand how to graph these things for your test. I don't think the graph is hard. It's going to be finding a line of best fit where all the work is. So the line of best fit is found by approximating its location and then choosing 2 points to write an equation like we did in 2.4 yesterday and the day before. So let's just see how it works real quick. Again, this would be your year, and this would be number of employees. And we have 2002 through 2008, 2, 4, 2, 3, 4, 5, 6, 7, 8. At this I could do 2000, 01, 02, 03, 4, 5, 6, 7, 8, 9. So that actually covers everything we need. Again, the bottom line is that you have everything you need here. And this goes up to 25, so I think I can do probably 3 again, getting us up to 30. So 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. And so we're looking at 2002 should be at 4. So 2002 should be about here with 4 employees. Again, low in between the 3 and the 6. 2003 says it should be 7 people, so slightly above the 6, which is about right here. 2004 says it should be at 11 people, so 11 is going to be closer to 12, which is about there. 2005 says I should be at 14, so again pretty close to 15, but not all the way up to 15. Again, just kind of giving the best idea. 2006 is at 20, which is pretty close to 21. 2007 is at 23. Of course, none of these are on our sheet here, but again, just bottom line is just making sure you have it in about where it's supposed to be. 2008 is at 25, which is slightly above 24. And again, we can see this has a positive correlation, and it's actually pretty straight, which would be closer to 1. But of course, this is only because we only have 1, 2, 3, 4, 5, 6, 7 dots, and this is actually made for us to find a line of best fit. So when you go to find your line of best fit, what you want to do is kind of pick 2 points and see if those 2 points represent about the middle. I think that this one, and I'm just going to start with holding it here and then kind of looking where it ends up. I wouldn't choose these 2 because that's going way off here. And I'm going to start at 1 and then kind of pick a point. And I think the best 2 points is this one going up to that one, because to me that's going to take us through the middle pretty well. And so what I'm going to do is use those 2 points to draw my line first, and then I'm going to use those 2 points to make my equation. Now you have to remember, this is in the chart. This is a 02, which means at this point is 2002 comma 4, and at this point is at 08, which is 2008 comma 25. Now what we have to do is what we did yesterday, which is we now find a slope. So we can make this thing here 2002 comma 4, 2008 25, 25 minus 4 over 2008 minus 2002, which is 21 over 6. And 21 over 6 reduces down to be, I think, 7 halves. And so that is my slope. From there we choose 1 point, so I'm going to use y equals mx plus b. I'm going to plug in one of my points, doesn't matter, but as long as you pick one of the ones that you chose for your line of best fit, your y here is 4 equals 7 over 2 times 2002 plus b. Nice thing about this is that you can go ahead and use your calculator. 2002 times 7 is 14,014. So 4 equals 14014 over 2 plus b. I almost forgot that part. Divide that by 2 because you can divide it by 2. You get 7,007 plus b. Move your 7,007 and you end up with negative 7,003, I believe. Yeah. And so my line of best fit is y equals 7 halves x minus 7,003. Now, here's where this works. And again, I have more time because I'm not there today anyway. This line of best fit is going to be used to anticipate what's popping up. So let's check it with this real fast. Notice that it says 2003 should be at 7. So what we should be able to do is take this 7 halves x. So again, take your 7 over 2. X in this case is 2003, so 2003 minus 7,003. And notice when I convert this that this says I expect it to be, again, this expects it to be at 7.5, but it's at 7, which is pretty close. Again, what I can do is I can arrow up. I can steal that by hitting enter, and then choose 2004, which says I should be at 11. Notice 2004 is at 11. At 2005, it says 29 over 2, which is 14.5. Notice how close that is. 2006, again, arrow up, go up to it, hit the enter to steal it. It's kind of like a copy and paste. But again, the 2006 says 18, not too far off, it's at 20. 2007 says 21.5, which is at 23. So again, your line of best fit in this case was no more than 2 off on anything, which means you did a pretty solid job. But that is how you do your line of best fit whenever you do this work. So again, the bottom line here, plot your scatter plot the way you normally would. Make sure everything is fitting, make sure everything is where it's supposed to be. Next thing you want to do is take your straight edge and kind of look to see what 2 points, like again, if you wanted to use those two, it would be bad because that goes under. If you wanted to use this one with the top one, it would go above it too much. But again, you want to find 2 points, and it helps to use a ruler, but of course I don't have one. But you want to choose 2 points in your data that seem to kind of identify everything. We could have even probably used that because it seems like it's pretty close. But find 2 points that seem to be pretty close to going through the material. Use those 2 points and do what we did yesterday, even though the numbers are ugly. That's why we have our calculators, and use that to create your equation. That is your line of best fit. So the last thing I want to do real quick is show you how to use common sense on your multiple choice questions, where there is a question actually like this on your SAT book that I have that I'm going to be giving you in a little bit, but it says which equation could be a prediction equation for the data point shown in the scatter plot below. And again, all this is saying is if this is your scatter plot, which of these equations could represent it? And what I want to do is use my common sense. First off, this has a negative slope because it's negative 7/4, which means it can't be A. Second off, notice that this y-intercept is too low. This is saying that it crosses at negative 200, which means that this would be crossing somewhere down here, and we know just by looking at that our line of best fit should be somewhere around here. So cross that out. That gives us 2 options between 11/5 x and 550 and 5x plus 600. And here's what I know about this slope of 5. 5 has a slope, because notice that these are counting about the same. 5 has a slope means I would go from this dot up 5, 1, 2, 3, 4, 5, and over 1, which means the slope of 5 is pretty steep. The slope of 11/5 is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 1, 2, 3, 4, 5. And notice how this slope has more of a slant to it, which seems to be more realistic with what I have going on. And so based off of that, I would choose B. Now, is that right? I mean, actually it is right because I saw the answer to it. But the bottom line is this: most SAT questions and things like that give you this problem are not going to give you 2 answers that are so close. But definitely a 5, a whole number like 5 is definitely going up, because remember 11/5 is more like 2 1/5. So that gives us, the way slope works, the higher the number, the more up it goes. The lower the number, the more it turns this way. And so again, 5 is more like this, 2 is more like that. And because this has more of a slant to it, 2 seems to make more sense. And there it is. So do me a favor and work on your Math Excel as much as you can. I try to put some questions in there you can work on that aren't too confusing. But again, if that happens, just go back to your other chapters and work on that stuff. But again, tomorrow I'll be back. We'll be able to talk about it and kind of go from there. So other than that, again, thank you for watching the video. Make sure you do your job in class, and good luck.